Hello, everybody. So tonight, continuing into the JavaFX GUI package, we talked about the background of it the other day, kind of looked at what you'll actually do in if you were to develop an application with JavaFX. For the most part, we use a markup language unless there's some reason to make it dynamic. It's better all around. We can use that drag and drop interface. I think I forgot to show the other day, perhaps while you were messing around with stuff, you notice on your own, but the text file and what's showing in Scene Builder is the same thing. So if you put something there in Scene Builder and then delete it in the text file, it disappears in the other one. So it's just reading, displaying that in live time. Your live time. So that's what we would mostly do. And our textbook was written before all of that was really set up. They knew they were going to make FXML for a while, but I think the actual release on it was a couple years behind the initial release of JavaFX. So we tend to do that. It ties back into the optimization stuff, and it's a whole lot easier to make a GUI dragging our mouse around. I think that's why for years it was standard to start people with into programming with Visual Basic and on Visual Studio, where we have that really nice drag and drop interface. NetBeans has one too. The latest version of NetBeans, they finally dropped it. It might have been last year's version. I didn't look at 13. I was using 12 for a while, and 12 still had the drag and drop interface in NetBeans that used the Swing, Java Swing package. We talked about that the other day. It was deprecated a long time ago, but they're stuck with it until they abandon backward compatibility, which is going to happen eventually. But there was a lot of stuff written with Java over the 20 years that it was the most popular programming language in the world. So now that it's dropped to number 2, so a lot of that stuff's still around, and a lot of programmers that learned it along the way, and it's still heavily in use. So they don't want to just revamp the entire language. Nobody's anxious for that to happen, but it's going to have to eventually. And then with NetBeans, the way Apache puts stuff together, that drag and drop GUI package, not including it probably means it's not turned on by default. So it's probably just a checkbox in the settings that you can go turn that back on, but it's a deprecated package. Scene Builder and NetBeans are the official software to use. Those are all. Oracle's set up as, instead of one massive corporation, it's like a hierarchy of subsidiary corporations. And then at the top is pretty much just Oracle itself is just a board of directors. And then all the work is carried out by their, it's the board of directors and some accountants up at top organizing it all together. And then all the work is carried out by all the subsidiary corporations, so that they can mix and match them as needed for whatever the state of the world is. They can quickly reorganize their big tech company and to whatever's needed at the time. That's been in the news lately, right? Facebook had that solid structure, right? They had that hierarchy, a traditional corporation. A small change in the industry, and that really disrupted their corporate structure. All the corporates, and not just the high level, the entire corporation, all the way down to the reason it was in the news this week, the 11,000 people getting laid off. Which I did want to work that in somewhere. So 11,000 software developers got laid off this week. Y'all are about halfway through a 2-year degree, which means within the next year, you're going to need to start job hunting. 11,000 software developers looking for a job may have an impact on that. It may turn out really well, because that could also springboard into a lot of new places to work, but there'll be a little bit more competition in software development positions for the next 11,000 is a lot of people, I'd say, for the next 3 to 4 years. And then things will settle back down to normal, but I thought it would be worth mentioning to at least point that out, that there's a whole lot of software developers that got laid off from Meta this week. If you didn't see it in the news, because I think the election probably took the head. Election usually takes the headlines, and then that's decided. Hopefully, it won't be a big deal. There's no shortage of software that needs developed. And there's plenty of there's still plenty of work. Like, yeah, there's no shortage of work, but 11,000 software developers did get laid off from Meta this week. So as you move from college to the working industry over the next year's time, that might impact your job search things. So, I guess be prepared and be patient for it. Be aware of it. That way it doesn't catch you by surprise. When you show up at an interview and it's like lots of people interviewing for the same position or something. But it could turn around and go the other way. A lot of those people are getting severance packages, really nice severance packages. So they may spring up a whole bunch of new software development companies. And then there's tons and tons of jobs available, and they'll send recruiters here to the school to grab you before you all even hit graduation day. So we're not psychic. We can't really predict the future, but definitely impacted the field that you all are studying for. So be aware of some changes. Otherwise, what the plan for tonight is to start looking at some JavaFX stuff. The way the book does it, all in Java. That drag and drop's easy. Right? Dragging it around, and after you look at the FXML file a few times, you will see the naming convention they set up their tags on. The attributes are the same as the data fields are named in the Java coding, and the little boxes are labeled in the GUI. So it also makes a nice little reference right there handy, so you don't have to go Google and search to trying to find a nice site. You can look over at Scene Builder GUI and see what a lot of the data fields you have in your JavaFX objects or classes are labeled as. They didn't change the name when they put them on the label, basically. So there's an extra resource right there at hand. So you can jump and narrow things down. That's another useful thing. We wanted to look at, kind of like the book does, putting it up in that code and address part of that issue that I started into the other day. That I have never found a textbook that I would call remotely acceptable in their GUI coverage. Programming textbooks, I don't know what it is. I don't know what it is. Programming textbooks completely drop the ball on GUI packages. Because that's what we think about with a piece of software, right? When you recommend a program to your friends, it's not because of what happens in the background. It's not because of how easy it is to type that name of that program into a bash shell. And it's because of using the GUI. And humans are a very visual species. There's all kinds of numbers. You can look them up. It's really interesting, like comparison of how much we trust our eyes over our ears. The reason stage magic is interesting. We know it's illusion, trick, sleight of hand, but it fools our eyes, and we know we can trust our eyes. So it triggers something in us. We're a very visual species, so graphics are important. And in every textbook I have ever looked at for programming, the section on graphical user interfaces, I keep using the word graphical user interfaces. And it usually has the S because it's like Windows. Right? We don't have the window operating system. We have the Windows operating system. There's more than one window there. So that does stand for that. And as normal for all of IT, not just the software development subfield of information technology. We use the acronym. And if it's pronounceable, we usually try to, which that looks an awful lot like the word GUI. It's really nice when it's a normal English word we can use. So I keep using that word, but realized I hadn't actually wrote it down. So GUI is a nice, easy acronym to pronounce. So we usually go with GUI. But I feel it's a very important part of software development. I remember when everything on computers was in consoles and terminals, and that's the only way there was to interact with the machine. And how amazing it was to see those early Macs compared to all the Apple IIs and early PCs around the school. Up in the office, when I went to school out in Washington County, there were computers there, some early PCs and Apple IIs all over the school. There was usually almost all the classrooms had at least one computer in them. But up in the office, they had some Macs with a GUI and a mouse. And it was so interesting to see those first times. And then when Windows rolled out, and even the first release, really Windows 95, that's when it really switched over. We didn't go back to the terminal after that. I thought it was done in the console, but that's not really the case. I was really, really excited when there was pictures to work with instead of all that text-based input and output. I thought I'd never have to do the text-based input and output again, but there's still an awful lot of that around. But that's a big part of software development. And for most textbooks, what they present in there, I wouldn't even accept as a dialog box. If it was the little message that pops up that reminds you to save before exiting, what they present in textbooks on programming, I would barely count acceptable is that, do you want to save before closing thing? Have you ever seen a textbook put 3 buttons in one of those dialog boxes? Because the save dialog box should have at least a yes, no, and cancel. But the standard programming textbook, you have like a GUI with 1 button in it. And it prints out words. And that button has words on it, not a picture. That's something else I was going to show because, the textbook, that's one of the, I was going to start at the top of the standard appearance and go down. So the second thing is that toolbar. I can go with that style, but really to put that in a hamburger menu is just to put it vertically at the side instead of horizontally at the top. We're still setting up a menu. They still behave the same way. I guess a hamburger includes a hide function. That's really easy. Visibility equals true, visibility equals false. Just flip it every time you hit that, click the button. Really easy logic there to hide and show that menu. So I was just gonna go with the traditional one. But that normal appearance. So there's another instructor here at Ivy Tech. I'm going to not mention his name this evening. But he has a story from, I guess, a few decades back. He was overseas, in particular in China, at a conference. And in the evening, he got back to his hotel room and he had a bunch of work he needed to do. So this was decades ago, before the days when everybody carried a laptop with them everywhere they went. So we had to use the hotel's computers. And they had it was probably around the time everybody was getting home computers. Some people had them early, but it probably wasn't until about 2006, 2007 that we could really say there was a computer in everything. We had access to them because there was public computer labs and things. So he went down to the hotel's public computer lab. I believe it was in China. He went to log on and do stuff, and all he had to do was enter a room number, where he was at, and they gave him a special password to go with his room number, and he typed that in. GUI popped up, and it was all in Chinese, obviously, because he's in a hotel in China. He didn't speak Chinese, didn't read Chinese, but he knew a lot about computers. And even though he didn't speak the language, maybe if I write really small, the marker will. That kind of shows up. I guess when I look at the screen, I can kind of see it. He didn't speak the language, but he saw a whole bunch of things up there that were clearly words. And underneath of it, a bunch of buttons with pictures on them. Then sort of that shape we would expect from a GUI, right? I don't even have to put things on there and you know what's up here. If I circle this one at the top left, you know what that one is, right? So he approached it that way. He had no idea what any of the words were. So before going and asking for help, he just come over to this side, not all the way over, because all the way over is the help menu. But usually somewhere near that, somewhere over the last 2 or 3 before you get to the help menu on the all the way at the end, and he clicked on one of them, started at the top and clicked down, and the second one, he saw what he was expecting. He couldn't read the window that popped up still, but he saw an American flag. So he knew that was the button to switch it to English. Just because of that standardization. Even though he couldn't read the language that GUI was written in, those conventions were enough for him to find the language button. Very, very important for software developers to stick with that. Y'all have downloaded software before, right? If we need something new, we'll go to Google, put in ask Google about it, and usually look for those best of lists. If we didn't have one in particular already, we'll look for, the 10 best, 15 best, 5 best for 2022, that sort of thing. And then we'll go through that list. That's the standard way to do it. And y'all have been through that process before. How many seconds are you going to spend? I shouldn't explicitly say seconds. How long are you going to spend on one of the things on that list before you go to the next one? If you can't figure it out pretty quickly, you're going to go to the next one on the list. Kind of like that. If we go up to the top left, we should be able to click that menu, and the very first button should be new. Something, no matter what the software does, we all know there should be a new button right here. So if we look at a new piece of software, we're not sure what to do, we go right here, click, see the new button, and then we start clicking around. But what if you decide, what if the new button's not there? You're probably going to look at the other stuff immediately, right? Like, nope, this is strange. I'm going to check the next one on the list and see if I already know how to use it. So that's something you want to look for, is make sure your users basically already know how to use your software. They're still going to click around, but those key things, like if the new button is right there where they expect it to be, that's going to buy you a little bit more time of them clicking around and like figuring out what to do. If they don't see that new button, if the new button's not up there at the top left, you just wasted all of the time you had to convince that user to use your software. They're going to go look at something else. And if they go use a different one, they're definitely not going to be recommending yours to their friends. Hopefully they won't be recommending against it to their friends, and their friends will at least take a look at it. But following those conventions can make a big difference. So I wanted to look at what we need to do to set up those conventions in JavaFX and get that basic appearance thing. And that start. So we'll have, right, at least we'll have a file, edit, probably view next. depending on how much time we have, a good simple example is to maximize and minimize the windows, so that would go right in view things. Call it zoom, but only 2 zoom settings instead of the whole switch case that gives different integer zoom levels and we jump between them. Not hard logic, but it is a little time consuming for a classroom. Maybe a help menu pops up a little dialog box that says how to use that. I'll go with the older style, and then we'll have little a row of buttons with pictures on it. I'll make them a little bit bigger here so they show in the video. Maybe not necessarily this big, but right there at the top left, that picture for a new file. Followed up with a the picture of open a file. The ones people know. I did try to change. I've tried a couple times different things and seeing how people react to them. I tried to change this save button, and one of the things I tried that I asked a lot of people about and got really good feedback, because everybody liked the idea after I told them that was the save button. But I tried putting a piggy bank, picture of a piggy bank with a coin being dropped into it. But when in focus group sort of testing, nobody figured that out at first. Once I told them that, they really liked that idea. They're like, oh yeah, that's great. That's way better than outdated floppy disk picture. Some of y'all probably floppy disks were outdated by the time you were born. So, but changing it up confused focus groups, and then it's back to the people aren't going to know how to save their work. Well, I would definitely make Control S work in anything there. So there's all of that stuff. So you want to stick with the toolbar with buttons that do the same thing as the menu. And then we have right click and keyboard shortcuts. And those are almost never mentioned in textbooks. Keyboard. And the right click context menu. You probably never actually heard the actual term for that. We say right click menu, but the technical term for it's a context menu. Because in most software that does something different depending on where we right click as well. But you want to include all of those. I don't look like a keyboard. There we go. That looks more like a keyboard. But we don't write different methods for doing that. Right? We write one new file method and then set up lots of events to cover it. Event-driven programming is what you're used to using on a computer. An event is anything that can happen. Keyboard presses, button, mouse clicks, location of the mouse clicks, mouse is hovering over things, time, alarms from the clock, like timer alarms, just anything that can happen. We can watch for anything the computer can detect. If the computer detects anything changing, some of y'all have me in an early class. In the early classes, I always like to start off with a thought experiment. Come up with your own definition of computer, not the textbook one or the one you'd see in the dictionary. That would work to explain what a computer is to somebody that's never used one. Oops. Oh, there goes that marker. It was barely working anyway. Blue one might work. But the definition I always use for that is my personal definition of computer is a machine that can detect, identify, and react to a change of state. So change of state would be like pushing a button. Right? If I come over here to my laptop, make quick adjustments, and it's just in this state right now, but if I come over here and push the B key or G key and these buttons, the state of those buttons is changing. The computer detected the change of that state and reacted to it. And now I'll change the state of the enter key, and y'all can see in the chat room there. Well, it was just randomly mashing the keyboard, but the computer detected the state, how the state changed, so it identified it and reacted to it. I always use that in the intro in the early classes because the programmers were the ones that defined the reaction. The physical hardware took care of that detect and identify, and then as software developers at Zoom in this case defined what the reaction was to be whenever that particular change of state was detected by the machine. So that's what we're doing here. And any change of state that the machine can detect can be, that's called an event. Could be a certain time of day, something happening, loud noises. Right? Pull up my phone and yell, "Hey Google." Make sure that didn't come on. Okay, yes. Put my phone off, I can say, "Hey Google," and then right, it just that particular sound in the room. Clicking buttons, tapping on touch screens, lots and lots and lots of things. Anything that can happen. And whenever something happens, we want to react to it. So the GUI wants to we set up methods for all this stuff to do all this stuff that we want our software to do, and then just start adding in events that can trigger that particular thing to happen. And one quick note here, I probably should have checked this page earlier, but the Wikipedia page for several years has had the same list up here on event-driven programming. Probably should have checked to make sure it was still there. Well, obviously the Wikipedia page is here, but on the Wikipedia page for event-driven programming, as opposed to menu-driven or procedure-driven or sequence-driven, there's this section about criticism, and that holds very, very true. It leads programmers to create error-prone, difficult to extend, and excessively complex applications. Okay. So we usually deal with it entirely in object-oriented programming. And one of our key concepts in object-oriented programming is inheritance. But when we start putting event-driven GUIs together, it's really, really difficult to deal with inheritance, because then that child would also be listening for the same event, would react to the same event, and then you have an entire tree of classes reacting to the same event. It makes it a little bit difficult. Error prone, because there's so many more things that could go wrong. Right? We write one new file method, and then we make 20 ways to access that method. But y'all have seen, even in console output things, we sometimes get strange interaction occurring. Anybody who's had CSS has seen a lot of that. Cascading style sheets, it can be predicted, but even those of us that actually claim the label mathematician and really like doing math aren't going to sit down and calculate that prediction for CSS. We're going to do some trial and error. But I go, well, that was a strange interaction, right? The cascading style sheets that it bubbles up first and then cascades down, so that all elements on the page are notified of any changes. And that means that anything you change in a cascading style sheet is going to tell every other HTML element on that web page 2 times that it changed. And And that repetition could cause one of the other things to react when it shouldn't be. So it's predictable. It's definitely predictable by math formula, but nobody's gonna sit down. We're gonna do trial and error and be like, oh, that was weird. We're making some slight adjustments. After 2 or 3 runs later, we figured out what it is 100 times quicker than we could manually run through the actual calculation to predict it. It's even more accentuated here because it's not just like CSS telling everything twice. We have 20 ways to create a new file in most duties, right? Control N, right click, and the context menu is going to have a new file, a toolbar, the file while I'm sharing my screen, and hit Windows E, and I'll go to the documents folder. Whoops. Press the wrong key press there somewhere. I go over here, I can right click here and create new folder, new files for a lot of things. Or there's a menu here. I don't even have to go into a piece of software. I can create new files for it here. When NetBeans starts, NetBeans has an empty file creation. When we go through those, if you look through those templates, we need that every once in a while. I think a text file's like that. When we go hit the new button here, I've ever put this in one of the projects. I'm not sure what's going to be deleted here. Into that, well, hopefully web application 1, something's going to be deleted. I'll put it in the source code. And yeah, it'll obviously be in the wrong place here. So I'll go in here and right click and go to new. And oh, it's already here, so I don't have to go looking for it. I can create an empty file. New file.docx. And now I just made a new file for Microsoft Word. The computer's going to believe that's a Microsoft Word document. So it doesn't even have to be our own software that we create that the new file comes from. I better delete that before it causes any problems. But that, oh, I should have opened that in Explorer. It's probably too late, and I have no idea why I closed NetBeans. That was just, yeah, I have no idea why I closed NetBeans. I better go ahead and reopen it. But be aware of these things. Excessively complex. That's the problem with it, that this is what your users are going to expect when you develop software. And your clients are going to expect this sort of thing. That's become the standard. So always keep those criticisms in mind. Difficult to extend, excessively complex, and error prone, difficult to extend, and excessively complex. Keep that in your mind and try to clean it up, refactor as much as possible. Organization goes a long way, but it's going to happen. Oh, and now back to this picture here. Then we have our main content. We have a big window that covers our main content, maybe some navigation over here. There'll be a tree view that takes a little longer, so we'll look at that later if time allows. And then down at the bottom, we have a status bar telling us what's going on, what all's happening with it. And usually up here at the top, we'll see the file path of the currently open file. And not just that, but that file path with the name. What does it mean if there's a little asterisk beside it? Everybody knows that, right? Or some sort of symbol. There's different ways to do it. Some maybe written in red. But it means that means we need to come over here and click this button. Those conventions that the users are used to. You want to keep those things in mind. They're very, very important. Otherwise, people aren't going to use the software you create. They're going to take the next one down the list, and it takes a long time to get that stuff together. And our book doesn't even cover enough to do all of this. They show HBox and VBox. They show some of what goes in here, just a small part of that. So I want to put this part together, and the stuff the textbook shows can get you started into this. And as time allows, we'll do that. But also, this is where I like to talk about observables and show some power programming in Java that we don't have in other languages. Get into observables and definitely, yeah. This is Tuesday, Thursday. On Tuesday, we will look at use JavaFX tables, which would be kind of like sync to a database like we were doing last week, and put table output with filters and all that nice stuff. And we'll look at observables that way. The first of the main reasons Java was the most popular programming language in the world for so long. So one of the very, very powerful things that we don't have elsewhere that makes a big difference. Yeah, we'll get there. So I wanted to start looking at this, and maybe we'll find something to put, a reason to put in, something to put in there. But what the textbook covers those in this. They don't even show anything except the add child method, and that's actually a small part of JavaFX. But hopefully you'll see a pattern, how the pattern forms. So obviously we can't look at all of it. So try to look at the patterns. Try to spot patterns in what we're doing, how they name things and how stuff goes together. Share the screen, and I'm going to open a new Maven project because Maven will go ahead and set that up. And instead of the FXML, I'm going to go with the simple JavaFX. And then Maven will go ahead and set all that stuff up for us. It should. I never did get a chance to look at, we can call this my GUI. I never did get a chance to look at why that HTML editor wasn't brought in. I'm pretty sure it's just a matter of what number or a word missing in the POM file, but yeah, I didn't get a chance to look at it. I was doing really good on my to-do list. I was rolling along, getting things knocked off. Almost had the VR stuff for next week's big VR day presentation. And I have a Quest, so I was wanting to test everything on the go, because the ones I borrowed from Bloomington are Oculus Go's. And I got all the way up to ready to install the side loader on the headset. That way I don't need another device to do it. And the side loader I always use to do that is an Android device, and our Android tablets in this cabinet I use as a podium mirror, which I hadn't opened in a while, and I didn't realize there was also 20 iPads. I thought it was still just like 30 Android tablets, and I opened it and was like, huh, where'd all these iPads come from? I apparently missed the memo of those coming in. But the tablets have a micro USB, and Oculus Go has a micro USB. And I definitely don't have a micro USB to a micro USB cable. I have lots and lots of USB cables. And my own stuff, I was able to use USB-C to USB-C, kind of a normal cable these days. But I went around to everybody I thought might have one. They just looked at me like surprised. Never had a reason for that. But it derailed all of my productivity today. Sorry, that was a little sidestep. So notice that there's less, there's not an extra folder. Was it this one? Yeah. So notice the other day when we did the FXML one, there was source packages and other sources. But here we have source packages, and then right below it is the dependencies. Oh, and is there dependencies up here? Oh, okay. I just realized why that didn't work. I need the JavaFX jar file brought in there. That's why that one the other day didn't work. I didn't get a chance to look at it, but yeah, that's why it didn't work. It needs the actual jar file brought in there. But we don't have other sources. There's a whole bunch of stuff here. I'm going to erase this stuff and talk about it. Yeah. Okay. Always generate this file. Let Maven generate this file. You can see there's not much to type there, but it does need to know those strings will be slightly different depending on your IDE, operating system, versions of Java installed, all of that. So, like capitalization differences. You'll see slight differences there. So let Maven generate that file, even though there's obviously not very much there to type. Like if there's a problem, create a new project that regenerates that file and copy and paste it over. Unless you've looked at it a whole bunch of times and you know what the capitalization on those strings are for your particular machine. Anything up here? These are things, the packaging, so part of that manifest, what's needed, what we have available, what to look for. We haven't been making this. This is one that's been automated in the background. So notice the two keywords. So when we start putting together modules, if another, as far as what we need, requires, and when we make our Java classes, somebody else is going to use those, import them into theirs. This is what we will be exported. This is what will be exported. So again, another very simple one to type, but it's an automated process. There'll be something generated there, so you can copy and paste from what's generated if you need to modify it. There is this Java doc. So we'll start with a basic thing that looks like this. Right? Follows our convention. They just called it application. I'm gonna give that a different name. If I go to refactor and rename, it should get the class as well. Basic GUI. And notice it rechanged that file name because we have that restriction. The class needs to match the file. So, excuse me. First thing we want to do, anything for JavaFX, it needs to be a subclass of application. And I'll come over here to important list, and you'll see right at the top, JavaFX.application.application. Which since the writing of our textbook, that was included in the language, and now we might have to build that up. They even did it automatically here. Application is in the graphics jar file, JavaFX-graphics. So I'll try to point that out along the way here. A jar file is a zipped folder of executable code. So a whole bunch of files in there and other zipped folders. So that's why this name does not show up on those dependencies. Yeah, I think the rest of them will be obvious. And you'll notice an error message we've seen before. Base GUI is not abstract and it doesn't implement our methods. So there's one that we have to implement. And that, so I'll do that override. Public method, void, we're not going to return anything with it. And it's start, is the name of it. Start. And we do need a parameter here. The parameter is a class called stage. I mentioned this the other day. They use like theatrical references. So we, our window is like a scene, and controls, you can think of the controls like actors, and the containers that we'll put them in are sort of like the script, maybe the placement, the little masking tape we put around the stage for where a particular person's supposed to stand, or where they're supposed to stop walking so they don't get bumped by the props moving around or something. The little marks on the stage, you can think of the containers that way. And then we build those up into a scene, and that's our actual window, what we look at. And then we throw that scene on a stage, and the stage is like the auditorium, it was already there. So the stage comes from the operating system. We only have one stage. Does that make sense? We're looking at that window, and so a lot of people at first think of the window might be the stage. But the window, the whole thing, like looking at NetBeans there, is the scene, and then the stage is where that sits in the operating system. So we take in a parameter called a stage parameter. And I'm going to do Hungarian notation. So the convention is, well, what we've been seeing in Java, variables and methods are in camel case. Classes are in Pascal case. And it's pretty standard to put anything that is visible, stuff that's visible on the GUI, put that in Hungarian notation. So a 2 to 4 letter prefix indicating what it is, and then some sort of useful name. And well, the only one on there yet is that it isn't so useful. Think about like a password input text box. We can call that the actual text box we put on the GUI. We can call that txt password. Then the variable that holds it is still can be called password, and the method that we use with it, we could call that the variable could be referred to as password. And there's going to be a lot of things we might build up in an object, have an object called password. So changing that notation allows us to use those useful reference names over and over and over again. And as then obviously import that JavaFX.stage.stage, and stage is also in that graphics jar file if you need to build it yourself. I guess I should definitely mention that because our book was written long before we had to build up the Java environment ourselves. So Maven handles most of the work. You saw the other day when something was missing, it couldn't automate the process. So I didn't think about the dependencies folder. I just added it to the POM and expected it to grab it. Because on Google Cloud Platform, the Maven package is there. If you put it as a cloud app on GCP, AWS probably does the same thing. it will automatically update when you add it to the POM, the manifest. But that being said, so have to keep track of those. And then we'll build our GUI here to do build the GUI. And then to do stuff with it, well, it's a Java application, so we need a main method. Right? It needs to be accessible. If there was more than one main method, it would be ambiguous on where to start. So static, that there's one and only one main method. It's not going to return anything because it's the very beginning, so there's nothing to go back to. Main, take in some terminal instructions because we get so used to clicking buttons, we forget that those buttons only call something in CMD or PowerShell or Bash or Zesh or whatever the terminal system for your terminal controlling your operating system is. All these buttons are just shortcuts to pass in the text-based commands there. And I'll just put args, that's traditional. That's the only optional part in a main method. We've seen that many, many times. And these always look exactly the same. We're going to do application.launch. And I always pass in args because sometimes we need them. We could probably get by with just launch in empty parentheses, but sometimes we do have parameters we want to pass. So users would be a common one. Who is currently logged into the system? Because anybody that's had a Linux class knows we usually pay a lot, very, very close attention to the users. We'll make 3 or 4 accounts for every single one of our users. So it's not like this just one account like we usually have in Windows. So we might want to pay close attention to that. That's the first thing that popped in my mind, but we may have several like that. Hit run. It didn't quite work yet. Could not find or load main class. Oh. I might have to change that in the manifest. Let's see if I go to properties. Packaging. I know where it's at for Ant and Cradle. I'm not sure where the spot to change the main class here is. Run. Uh-oh. Well, let me see if this fixes it. Refactoring apparently did not change that unless it's under. Let's see if cleaning the project will work. Okay, refactoring should have automatically changed where that was. And I know where the button is in Maven or not. I don't know where it is in Maven. I know where it is in Ant and Gradle. But you'll notice that this menu looks different than the menu we've been pulling up all semester. So, well, actually, I found the button. It's right here. It's this button right here I need to click, but it's grayed out. So I said, maybe I can change the default configuration. So, oh, that's not where it's at. Well, I'm gonna see if changing this back to app fixes that. Actually, I got a better idea. I'm gonna copy this and actually delete that file. And make a new one. See if this fixes it. Well, there should have been a little box pop up asking me what the main class should be. So I guess I have to change that. Source. Oh. Sorry, I have to track down this button. Oh, set configuration. There it is. Customize. There we go. So I went to configurations, added a new configuration. I just made up a random name. And then under run, I can switch to that configuration and choose what the main class should be. It's still looking for something called app, so I'm just going to change this back to app. Maybe that'll fix it. I'll highlight what I was looking at. So notice it says it can't find MySQL.app. So apparently refactoring missed something. Sorry, I did not realize this was going to waste a bunch of time. Not like we have a whole lot of time in the classroom. Rename, let's go back to app and see if we can find it now. Okay, didn't crash, but nothing's happening yet. Something's happening, but we can't see it here. I go over to Task Manager. Oh, where's my name? There we go. Get it where things aren't moving. See, NetBeans has a bunch of things going on, including 2 console window hosts. One of those is running the NetBeans application, and the other one is our stage. So we activated the stage, we just didn't put anything on it. We unlocked the door so that the set builders can get in, sticking with that theatrical reference. So that sets up our stage. That's the part that connects back to the operating system. And it is a native platform. So it's going to asking Windows what a window should look like, or that's a Mac, what I guess that would be OS X. Right? It asks the operating system what the GUI and the buttons, it asks what it should all look like. So it looks appropriate running on every system. Native is the word you want to look for when you set up a GUI. Pick a GUI package, because that's the one that will always look appropriate for the system. Let's see, what's a good start here? I'll put a label to start with. We'll get rid of that in a moment. After a break, LBL temp is a new label. And I already started typing it. So if you weren't looking at the screen, can you guess what goes into a label constructor? We do need one thing there. It's a label, it's a spot to write text that cannot be changed. So not an input text box, just some text to show. So we need to know what text is going to show. A new label is temporary because we need something there. Whoops. And then import that. And most everything else we're going to do for a while is in the JavaFX.scene.control. And you'll see there's one of the jar files is controls. So I'm going to quit pointing at those because until we get to something that's not in the controls package. Which actually I don't think is going to happen tonight. Everything else we do tonight is going to be in that controls package. That's where most everything is. That's the controls that we can click on. So once we have that, well, we get our widget, and I'll go through the whole basic idea. Then we need something to put that in. I'll create an H box. H box for horizontal, B box for vertical. That's our two basic controls. We have lots of different ones. They're organized. That way it puts everything in a nice little row or column. Like our toolbar, everything goes across. Or our main menu would also be an H box. We have here on NetBeans, there's a tree view on the left and text editor on the right. And then other things and then overall, those two H boxes are put in a V box to stack up and down. So, whoops. I'll try that without bumping the laptop touchpad. So H box. And one of the easiest typos to make is to make that B lowercase. I do that all the time. H box and V box have a capital H and a capital B. So two capital letters. And I'll put it in Hungarian notation, HPX container is a new H box. And in our constructor, we can put this here, but we could put what is there and then obviously the imports again, which you'll notice is in the scene folder, and layout is parallel to the control folder inside of there. Since we already have that, we could put LBL temp in here and that's just going to go in there. But to point out the patterns, because that's going to be important here very, very shortly when we get to menu bars and things that would be set up different than anything our book shows. We want to set up this, the children. So what we do is go to the H box container, whatever our container object is, whatever is holding the other objects. And first thing we want to do is get children. A lot of people at first want to automatically jump to set children, but this grabs the list. So this grabs the list of all the child nodes that we already have in the container. Right now it's an empty list. And then .add or add all. And I would recommend add all because obviously one will work there and then you don't have to remember multiple methods. Or if you need to add something, if you realize you needed to add another child in there, you don't have to change the method. So you just add a second one. Kind of like the curly braces on the if block. We can leave them off with one line, but it causes more problems when code expands later. So if we do add all, we can either add an entire collection of nodes, or we can add nodes one at a time. Or we can pick by index out of a different collection. So if we have them in a different list, we can choose the index. Start off with this, well, we only have one. Oh, and everything's a node. It is a graph structure. We'll draw a quick picture on the board. Graph structure, so we have nodes, and you're probably used to nodes in like a tree hierarchy. You're probably used to nodes like that, so that's a tree. Graph is more general. We have a bunch of nodes, and then there's just assorted connections between them. That's one possible graph. We could have a fully connected graph where everything's connected. The connections aren't necessarily as rigidly defined as they are in a tree, and they can be dynamic. We can get rid of this connection and change it to connect over to that one as if we need to. So nodes, like we have a tree, but we have control over taking it apart and reassembling it any way we want. Or we could do fully connected and just, I might as well draw those other lines. Make it fully connected so that every node connects to every other node. And this one needs that, and that, and that. This one needs that, and that, and that. And just every possible connection between our nodes is there. We have control over how those nodes, a lot more control over how those nodes connect. We'll talk about data structure soon. I was going to make a point about that, but we'll talk about data structure soon and the trade-off for that control. So obviously we don't get anything for free. If we're getting control, we have to give up something else. So we're adding nodes, however many we have. Let me add 2 just to see the syntax. LBL another is a new label. And I'll put the words another on it because these are going to be deleted. And I already used temporary. So then we just need a list of things to put in here. And once all of that is ready, we get all the stuff we want. We create a scene. I'll call it SCN main. The scene's visible, so sticking with that Hungarian notation. I'll do the import so that the underline will go away when we get a semicolon at the end. Notice once again, well, we're in .scene folder, which is in the controls jar file. That's going to be a new scene. And we need a couple of things in here. First off, what is the container? So we'll put a bunch of things in containers. We'll have lots of containers, then shove those into like a final big panel. We're going to look at a border pane after the break. But we'll have layers of containers. And then the top layer of container obviously is going to bring all of the others with it. So whatever containers we have, which is there's only one at this time, we'll put that in. But we also need to know how big is our scene. So in pixels, width and height, which you probably knew went here somewhere, just not exactly where the width and height. And just to express a point, I'm going to do 300 by 700. Probably not the final size that I want to go with, but just in case you ever forget which order they go in or need to confirm that, do something obvious So you can easily tell which direction is 300 pixels and which one's 700 pixels. Now that we have our scene, do I have anything else to talk about in the example? Events. Look at those. Oh, now that we have our scene, we're ready to throw it on our stage. So we have this stage main. Our main stage has this method set scene, and it already predicted the only scene we have available. And I just pointed out, just type the set scene method, so hopefully you can figure out really, really quick. Then we can make more than one scene and swap them out. That's how we can swap out the panels. That's not the same as the dialog box. That's basically everything that shows. Remember when we ran it with just the stage, all we got was a console in the background that wasn't doing anything. So the scene is what we actually see, and we can swap out scenes on that main stage, which is probably easiest to think of in, like, say, a video game format is level 1 to level 2. We swap out the scenes, but we're still in the same application. Might as well put this in here. They may have fixed this, but in the previous version of the textbook, it did not show how to put a title right up there, the little title bar. And that was one of the ones I drew on the picture, so I'll go ahead and put it here now. I'm gonna put class. It's just set title. So you probably could have guessed that, but that seems like one of the basic things we would want to do. That's not a bare minimum, but I wanted to go ahead and show it. And the previous edition of the textbook had that left out, so maybe they edited it in. But the only thing I reread in that 1,500-page textbook was the programming assignments. In particular, the programming assignments that were assigned for the class to make sure none of those have changed. And once we have all of that, our main stage has a method called show. So back to the theatrical naming, open the curtain, showtime, open the curtains so the audience can see the scene. So you can see that obvious thing I put in there. That's not a good size, but it makes it very, very obvious as to the order of width and height. It's often a lot better just to, so whenever you can do an obvious check like that, to just throw it in. And notice how the labels just pile in left to right. If I change that to a V box real quick, new V box, I'll just keep the same name on there, run it again. And now the first one in is at the top, and it goes down from there. I'm going to switch that. 720 by 480. Those numbers don't really apply anymore. We used to be able to just go with that's the aspect ratio that screens are, but that changed a long time ago, and screens aren't all the same aspect ratio. Used to be really nice. We'd say, okay, this always gives us our aspect ratio, but screens aren't even all flat anymore. We have both concave inward and concave outward, concave and convex screens to show in different situations. Flexible screens, small screens, big screen, phone screens, wide screens, tall screens, billboards, there's watch screens. They're not all the same aspect ratio anymore. So you might sometimes see those two numbers because of how cathode ray tubes work. They only had so much range. So back in the day of cathode ray tubes, when we were actually throwing electrons at a piece of glass, we had to go with certain sizes. But Now the cathode ray tubes are a thing of the past. We do not have the same screen aspect ratios on all screens. So there's the bare minimum to get something up there going. We can go back to V box because that, or H box. Oh, I didn't know that would happen. That's apparently a new update on NetBeans. It erased the import that was no longer there. That's new, and if it's been happening for a couple months, I haven't noticed it till just now. I wanted to get spacers out before the break, but it's definitely time for a break. That's our basic thing. I guess we can look at spacers after a break. I was hoping to get spacing those two. Spacers and padding. It takes a couple of steps. So I'm almost positive that our textbook does not show that, because that's getting into something looking nice, and programming textbooks never bother to cover looking nice. But it's time for a break. Does 10 minutes sound good to everybody? Two big head nods here in the classroom. Zoom, about the same thing on a Zoom call. So my laptop says 7:17. We'll get back to it at 7:27.